if I put any other number, so at least one number is 0. If this is true. What if two numbers multiply be 4? One of them could be 2, one of them could be 1, because the other one could be 4. One of them could be 8, if the other one is 1/2. One of them could be 40, if the other one is 1/10.
One of them could be -1 if the other one was -4.
Kick ass, right? And how long would this list go? For freaking ever? Until I'm dead, my kids can take over. Right? If I ever have kids. So the only number that lets me find a specific answer is 0. If I have two numbers multiplied together and they give me 0, one of them's got to be 0. So if I had A times B is 0, you can actually tell me two things. Either A is 0
Or B is 0.
or B is 0. So those would be the answers to this. Maybe. That's what this is saying, and this is what it sort of looks like when I do an actual problem. When we do problems, we're not going to have multiple variables. Don't freak out. That's just the idea. So what are we going to have? We're going to have this. Does anyone see how that is? Two numbers multiplied to be 0. What's one of the numbers?
X minus 7.
X minus 7. Good. That's a number. And that's a number. So that number times that number is 0. Therefore, either...
One of them 0, right?
Beautiful. So either this one is 0, so how would you write that?
X minus 7
equals 0.
X minus 7, either X minus 7 is 0, or...
X plus 5.
Or X plus 5 is 0.
So what's this give me?
7 plus 7 plus 9.
X equals 7. Or?
Or X equals 5. Negative 5.
Cool. And of course, negative 5 plus 5 is? 0. Negative 5 minus 7 is? Who gives a shit? Because it's multiplied by 0. Do you kind of see what I'm saying? So negative 5 minus 7 is negative 12. That's nice for it. But negative 5 plus 5 is 0. So it doesn't even matter what that guy is because the other guy kills him, right? The big mistake I see is related to the point I made about this number. If I had X minus 7 times X plus 5 equals 4, there's not a damn thing I can say. I can't say shit. Neither one of them have to be 4. Neither one of them have to be 2. Neither one of them have to be 1. Neither one of them have to be negative 1. Because there's a million different things. There's more than that. There's an infinite number of things that go, holy shit, no. I don't want that. There is a way to do that problem. We're going to get to it. Let me kind of work that my way up there. All right, let me remember this. We'll do this one here in a little bit. Put it over here. I don't need you going. Can you guys see where the factoring is going to come in? Because I gave you a problem that was already worked. It was almost done. What did somebody do before this step? Where did this come from, do you think? They must have... They factored it. Okay, so the actual problem we're going to see would be something like this. So here's the thing. I really want to point this out to you. Why are we solving equations in a different way now? Because can you get x by itself? Can you combine these? No. If that wasn't there, how would you solve it?
Divide by 9.
Yeah. Subtract 20 or add. Get that on one side and then divide by the negative 9. I like it, right? Bam! There it is. We've done that before. That would never change. So what has changed in this equation, though, is one of my x's is to a different power. That's the trigger. That's what tells you I need a new way to do this because the old way don't work. You guys understand? If this was x minus 9x plus 20 instead, right? That's not a square. What would I do first?
Minus.
Yeah, this would be
That'd be 8x.
negative 8x.
Plus 20.
Subtract 20. Divide both sides by negative 8. I like. Then it would be 10. It would be, what is it, Jeff? You can do it. 5 over 2. Right? Now, so that's because if these are the same power, I can combine them here. Oh shit. I need a new method to solve this, and that's where this, what we call the zero product property rule, whatever the hell we want to call it. If the product comes out to be 0, I can say something about the pieces. One of them's got to be 0. That's the key. So how do I do this problem then? What do I have to do?
Multiply.
No.
Multiply it.
No.
Yeah, good. Two numbers that multiply to be 20.
Oh, okay.
Add to be -9.
4 and 5.
1 and 10.
Negative 4 and 5.
Negative
Negative 10.
4 and 5. Oh, negative 8.
Negative 10 and 1.
That's the one.
They don't multiply to be 20.
Negative
Negative
4.
4, negative 5.
Yeah, -4.
Negative 5.
-5, they add to be -9, they multiply to be 20, right? So just because I put an equal 0 in there, the factorization process doesn't change. You factor like always. Now you say, okay, I can do more now. It equals 0, so therefore I can say either
Negative
X
4.
equals
x minus 4 is 0, or
X minus 5.
In this case, x is
so x is
4.
4,
4.
or x is 5. So real quick, if I want to check this, what do I do to check it?
Put 4.
Put the x
In the beginning, if you put it here,
Yeah.
it's not a good check. So if I put it here, what's 4 squared?
4x squared.
16.
4 squared, 16 minus 9 times 4,
Times 4.
36. Plus 20, what's 16 minus 36?
20.
Negative 20 plus 20 is
0.
0. Check, right? Stop there for a second. You can, no matter what the equation looks like, you can check it by plugging the stuff back in. It's supposed to be the answers. So really, I want you to understand why the process works, and also why did we even make this process up? It's when I can't combine my x's. My old way of solving equations doesn't work anymore. Yes?
Looks like it's x minus 5 at the bottom.
Totally is.
Yeah.
Oh, I see here?
Yeah.
Yeah. Man, you guys are really picking on me today. Yeah.
So when you answer in the homework, it's going to be both of those, x equals
Good.
4 or
Both
x
of those.
You have to
And you want to see something really cool? What's the highest power in that problem?
2.
How many answers did it get? If it was a 3, I have to get 3 answers. If it was an 18, I have to get 18 answers.
Okay.
They could be repeats. I could have all 18 answers be the number 5, but there's going to be like 18 5s.
Could you put x equals 4 or 5, or do you have to put x equals
No, yeah,
4?
no, yeah. I'm just being really explicit, but if you did this, bam, that's fine.
Okay.
That means either one of those work. So every equation we saw before, we only had one answer for the equation normally, right? We only have one answer. Now I got 2 because the power's higher. It allows for more things to happen. In fact, does anybody know what that would look like? This is going a little beyond what we need to do for this class, but we've talked about this before. What would that look like if I graphed it? We look at a parabola. And so it might be like this, and say, when I say, okay, where's it equal 0? 2 places it equals 0. A line, where's it equal 0? Only 1 place. There you go. A cubic, just to freak you guys out. Here's what a cubic could look like. 3 places, and that's really why that idea of whatever this power is, that's how many answers I must get. That's a real quick visual of why. Exactly. If it was 4, it could be. We call this, sometimes we call this the butt graph. What we'll do. But 1, 2, 3, 4. That would be a 4th power.
What level is that? What level?
This is the 4th power. Or what level of
What
math?
level math, yeah?
A little bit in 110, but definitely in pre-calculus to study the hell out of this.
What if like there's 9?
Keep going.
18.
I mean, odd power looks like
Up and
this.
down.
It just has more oscillations, right? Any even power looks like that. Odd power, even power, right? Or from your perspective, I guess it's that. For odd power. Anyway, that is all beyond us, but I like to do that. Not to be mean, but just to kind of show you why some of this makes sense.
Why we shouldn't stop.
All right. Yeah, exactly. So you guys try this one.
I know, right?
Do not collect an A.
So what about this here?
Oh yeah, I like that. Don't say anything out loud. Just try it. first step, you just forget there's an equal 0. You just make sure it's equal to 0, and then you just think factor. You just think chapter 6. Right, and this is, we're still in 6, but we keep going. So what do you get when you factor this?
Negative 12.
Negative 12 plus 1.
I like it. Gotta be opposite signs, multiply by negative. I like it. The bigger one's negative. Some of you guys might be to the point where you don't have to write what I'm about to write. That's good for you. So that's fine. You should be able to look at that and tell me what x makes this negative, what x makes this 0.
Positive
12, right? Maybe you can see that. And what x makes that 0? Negative 1. If you don't, you can just say, okay, either this guy is 0 or that guy is 0. So I get 12 or negative 1. Kick ass. And then you can always check it by plugging it back in. So what's neat is those are the places on the x-axis where the parabola would hit. If you think about it visually, that's what that means. So what happens if I do have something sort of like that? I'm still working in that direction of that one up there. What if I had this here? What you got, Jeff? I don't know, man. No, don't freak yourself out here, buddy. Oh yeah, I like it. This will mess with your mind a little bit. That's all you do, man. Is yeah, what is wrong with this equation? Why? What do I need to have happen, and why? What's wrong with the equation?
It's not equal to 0.
It's not equal to 0. Why must it be equal to 0, though?
So we can do it.
Yeah.
Define the answer.
This is true, but why in this case? We didn't do that before, did we?
Because 0 cancels out.
What is in that equation that wasn't in equations before?
0.
Very plus a
No, I mean not today, but I mean before, way back in time. That piece.
Oh, 7?
It's because I have an x with a different power, with a higher power than 1, right? Anytime you have an x that's to a second power, third power, something is not an x to a first power, you've got to get it equal to 0 and factor it. Because normally, if that wasn't there, what would I do? Oh, I'd get my x's together. Right there, I'm screwed. If that's there, can I get all my x's together?
no.
No, I can't, because these are not like terms. So I can't use the old process of solving equations if I have an x with a different power than 1. Because then it's not like terms. Oh shit, so I'm desperately trying to get you guys to realize when you see this, x to a power that's not 1, I want to get it equal to 0. That's the trigger. I don't like teaching that first, but now I've told you the idea, I can say that. That's what you're looking for. So how do I do that? How do I get it equal to 0?
Do you factor the left side?
When do I factor? When it is already
0.
equal to 0. So is it equal to 0 yet? No. So I can't factor yet. How do I get it equal to 0?
Can you divide?
Subtract x.
Subtract 7.
Subtract 7, because what's left then?
0.
0. Subtract x. Subtract 7. So if there's stuff on this side, move it.
Oh, okay, so you can
That's the idea. So you move all this shit over, what's left? 0. And what do you get here? You get x squared.
square minus 3
Equals x2 minus 5 equals 0.
I like x squared minus 5x. That's it. The 7's cancel. I like it. And that's not it. Now you can actually start to solve the problem, right? You got it looking the correct way. Because there's an x with a different power on it, I got to get it equal to 0. I'm there. Now I can start to solve the question. Now I can start to solve it.
In this case, we don't have a third term, right?
We don't have a third term. Good.
Is it plus 0?
That's 1?
You could, but there's no need. When you're going to factor, that's what I'm doing right now. I'm just thinking I'm factoring. What do you always try first when you're factoring? GCF. If you remember that, you're going to save yourself from simple mistakes. What comes out of both of these? X. The people that try to make this become this,
I did it.
oh, I don't blame you, because they're so used to that. But always think GCF first. It'll save you. If there's not a third term, something must be weird. So you got to stop yourself and go, whoa, I don't want to go into automatic, pilot here. I need to stop. What comes out is an x. What's left?
X minus 5.
So either what?
Either X.
Either x is
0.
oh, kick ass, or
5.
x minus 5 equals 0. So x is
5.
5. If you don't need to do this work, don't. That's fine. If you can see that 5 works, then you say x equals 5. Just be really sure you're right. Cool. All right. So I think we're ready to try that dude over there. You ready? Maybe. Why? Let me ask you.
Don't forget the perfect square.
Oh yeah, shit. All right. I want to keep going with this idea though. Why was it so easy to bring this over and mix it in? Because this is all separate terms, right? It's a weird thing I'm trying to say, but these are all separate, so I can put the x's together, I can put the numbers together. So the problem with that one, well, in Roman numeral 5, if I try to subtract, no, Jeff, you're thinking that. If I try to bring that over, I can't put it with anything because this is all contained. So what do I do first on this side?
Multiplication, like distribute.
Multiplication. Distribute. I love it. I should have actually figured out if this has an answer. We'll see.
X squared 5x negative 7x 35. And then
So what really, the way I look at this is somebody factored too early. And I'm like, oh shit, let me undo the factoring so I can bring the 4 over. It feels like you're going backwards, and you are. You're sort of going backwards, but you have to. So you can bring the 4 over, so now I can...
Minus 39.
Put those together, right? Is that cool? Now we hit a roadblock, right? Which is fine, actually. It's fine. I want you to realize that this method doesn't always work, because this method requires us to be able to factor. Can we factor everything? No, we can't. Is this factorable? What are the factors of 39?
Negative 1 and 39.
I like it. Negative 1 and 39?
39. Negative
3 and
1.
38.
13, yeah, this would be plus or minus, plus or minus.
Okay.
I like it. And that's it? Shit. Can any of those make 2? No. So if this did happen to you, which I would be highly surprised about, you would just say, can't solve. There are actually answers. In fact, how many answers are there?
Infinite.
No answer.
No answer. All of them.
There are 2 answers. They just don't look nice. I really... Do you remember when I did that weird-ass thing the other day, and you guys probably just wanted to forget about where I factored this? I had to use radicals. I had to use square roots, right? So we don't... So factoring... If I don't use that, if I only get whole numbers, it'll only give me answers that are whole numbers or fractions even. We'll see one in a minute where I get fractions. It can't give me answers that are like the square root of 7. I can't get that. So this kind of problem, some of you guys already kind of maybe know what you have to use. There's a formula, the quadratic formula. Oh shit. Yeah, we're not going to talk about that yet. That's what you have to use to solve this, but factoring doesn't work. So right now you just say can't solve. Don't say no solution because you know better. You know there's 2 answers. We just don't have enough math to get them yet. Cool, I like it.
So we can just take
So here I would just be can't solve. Or leave me alone, Jeff, or whatever. We can't solve yet. Can't solve. Yeah. But I don't think the homework would do that. That's a little bit overly evil. So officially it's prime, but that's not the answer because the question isn't factor this. The question is solve this. So the answer has to be an answer or no solution. But I know it's not no solution, so I just say I can't get the answers. That's what I know. I like it. You see how weird they get here? Yeah. Okay. What about this here? Yeah, maybe I shouldn't use Z. All right, let's make the Z. Just make it an X. That's the safest. My Y's look like 4s. 5 is a scary number. I know.
Yes.
Get it together.
Minus 12x squared and minus 12.
No, you don't want to do that. So you do want one side to be 0. But
Yeah, so you just move the right side over to the left, or move the left side over to the right.
yeah, which way? There's a way that I want to go that's better.
I'm going to say the right side over the left.
Left side to
I
go.
want to keep this number positive, right? Because that's going to be my first number. I want that number to be positive. I always want to try to make my x squared piece positive.
So we
So I want to move this stuff over here. So I want to add 4x,
4x minus 5
subtract 5. So I get 12x squared
plus 4x
plus 4x
minus 5.
minus 5 equals
0.
0.
But I think we can do it, then we can take
Totally
minus 1
can.
from the
You totally can. But I don't know if you guys remember in the homework, you did see a couple problems with a negative there. If you try to do it, it's not as easy. It's more difficult. I always try to keep it positive just to make it not too weird. Yeah. And now, how do I factor that?
GCF first.
Okay, GCF first. I like it.
60
So negative 60,
plus 4.
that makes positive 4. I like it.
10 and 6.
10, 6.
10 and 6. I like it. Which one's got to be negative?
Negative 6.
6.
Sorry, I didn't mean to make it a trick question. And then what do I do with that, of course?
12x squared
12x squared.
plus 4x.
I would do this.
Minus 6x
12 times 5.
plus 4x
Minus 5.
Plus 10x. Minus 5.
equals 0.
Because it doesn't matter, you have a choice of how you do it, and why do I do it this way? So that that's plus, so I don't make a negative mistake. Comes out of there.
6x.
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 No reason to make a negative 6x is positive. I don't want to change that.
2x. Minus 1.
Good. 6x divided by 6x. 1. You guys still want? You guys good? A little bit.
Yeah, hold on.
Yeah.
Too fast.
Oh, good. You gotta let me know if that's true.
6x plus 5, 2x plus
Yes. I'm not done yet, obviously, right?
Yeah.
So what comes out of these two? I gotta take that 5 out.
2x.
Thankfully, I'm left with that.
6x plus 5. Right, 2x.
Let me stop there for a second. Yes, sir.
You factor 2 out?
From where?
Never mind.
Yeah, if that was even, I could take the 2 out. Yeah. And now, don't stop there. Sometimes people forget to write the equal 0 and they feel like it's just a factorization. No, it's to solve this equation problem. So I got to end when I get x equals numbers. So either what?
Either negative 6x plus 5 equals 0,
Or,
2x minus 1.
right? And then you solve those. So how do I solve that?
Plus 5?
No,
minus
Minus 6x minus 5.
divided by 6.
So there's one answer, right?
What?
What happened, guys? We know how to solve 6x plus 5 equals 0. Right? Get the number on that side, divide by the coefficient. When you write this little equation, it doesn't matter that all this shit is on top of it. You just care about solving that little equation. I think that's part of students' problem is you just have to do that, but your brain is thinking about all this other shit. No, that shit's done. Let go of that. You just need to solve this little equation right there. Is everybody cool with where that equation came from? The 6x plus 5. Because right here, it's either this is 0 or that's 0 because they multiply to be 0. So one of them's got to be 0. So either that's 0 and I get negative 5, 6 for x. Alright, so there's still some... So of course, how do I solve this equation? I move my number over,
Okay, then you have
then divide by 6. Yeah. So there's one answer. And then here, same thing. Divide by 2. 1/2. Cool. So x is negative 5, 6. Say again? Stay in what form? No, because that's not an answer. When do you know you're done with an equation? When you can tell me x equals something. Or maybe several things in this case, right? So you know you're not done here yet. Yeah, so your answer can't be here, Jeff. The answer's there to solve it. No, it's not my job.
And if you plug in those answers, will give you...
Exactly. If you take 1/2 for either one of these and plug it back in here, it'll work. You ready?
So, either x is -5/6, or either x is or x is 1/2.
Beautiful. And I really want to make sure you understand. Either one of those numbers makes this equation work. That's the idea. I like it. So if I didn't have this, I would only get one answer. Only one thing could make it work. Now I have a squared, 2 things could make it work. A cube, 3 things could make it work.
That does really the sign instead.
I like it. Cool. All that curvy shit lets you have more intercepts,
So that's
more
two-
x-intercepts.
Two points.
Yeah, in this case, we've got
Either side.
2 separate points. When I plug in 1/2, what's 1/2 squared?
1.
No. All right, we'll try that. 12 times 1/2 squared.
That's 2 over 1, that's 1.
1/2 squared is 1 over
1 of 4.
4. Right? 1 squared is 1, 2 squared is 4. 12 times 1/4. Is that equal to 5 minus 2? What's 12 times 1/4? What's 1/4 of 12? 3. And what's 5 minus 2?
3.
3. It works. 3 equals 3. And if you plug negative 5, 6 in, it would also work.
It's more evil.
Huh?
This one is like more evil.
More evil.
Oh, that's too bad. But the only reason it was even at all evil is because fractions happen. But when did fractions happen? When I was done. Really. What am I doing here? Checking it. Do you always have to check it? No, you can if you want to, right? So we all hate fractions, but the nicest place for them to show up is at the end. Because then I'm like, oh, it's a fraction. Next. Even that, you should not be scared of fractions anymore, but oh, that's all right. Calculus students are scared of fractions. What can I do? Okay, so everybody got a practice test, right? Let me officially make this true. 6-7 is extra credit.
6, 7.
Because 6-7 is not really different, so it's the same thing, but I'm going to make it extra credit, just so you don't have to do that homework if you don't want to. You can do it if you need to, if you like to. Cool, you're welcome.
Thank you.
So everybody got a practice test, right?
You didn't do 6-5.
Yes, I did.
Perfect.
I did 6-5.
No, you didn't do the exam.
Oh, all right.
Monk was it?
Anyone, man.
What the hell? Correction. Correction is...
He does.
All right, guys, if you want to see this, if you don't, you can leave. They teach you, you have to notice it's in that form. And to me, that's so silly. So this is twice 3, and that is 3 squared. And I notice it's in that form, and then I can use a special way. It's a bunch of crap. Attack it the same way we always do. What factors of 9 make 6? 3 and 3. So that would be a plus 3. A plus 3. Which you can write as a plus 3 squared. So you don't need a special form. I don't like when they make it feel like there's more to remember. I can attack anything that looks like this the same way. I don't need to know these special forms necessarily. Now, if you like them, sure.
No, I didn't understand yet.
Okay. Just attack this the way we always do. Yeah. Oh. Thank you.
Oh, sorry.